Okay, so I think we can go ahead do a little bit more here on numerics. Okay, uh, so what we'll be doing a lot of, especially in when we start analyzing reaction kinetics models, uh, starting tomorrow, is we'll be getting outputs, time series outputs in the form of NumPy arrays, NumPy matrices. And a matrix, it's a two-dimensional array, which has rows and columns, and we'll be dealing a lot with those and indexing and slicing those. So the big difference, so NumPy, that's really the core scientific matrix library that we use in Python. It is it's pretty much exact. It is actually exactly equivalent to anything that you can do in MATLAB. You can easily do in NumPy. Actually, usually a lot easier. The one big difference between a NumPy array and a Python list is a Python list is what's called heterogeneous, meaning that it can contain objects of different kind. So we showed we had a Python list that contains strings and numbers and characters and all sorts of other things. That works great. That's really flexible. But the problem is it's not terribly efficient in terms of performance. It's a lot of that. It's very costly. That flexibility comes at a really high cost. So what NumPy does is NumPy arrays are what's called homogeneous, and NumPy arrays can typically only contain numbers of the same kind. So we can have a NumPy array of 32-bit integers. We can have a NumPy array of 64-bit integers, a NumPy matrix of floats. I think you can have, I'm not sure of what the limit is, but I think you can have up to, I think, 15-dimensional, you can have 15-dimensional matrices in NumPy. And I would have to look up what the exact upper bound is. I've honestly never used anything more than a 4-dimensional matrix. Actually, technically tensor, but whatever. Okay. So to use NumPy, so NumPy is a package. So we simply do import NumPy as NP. And honestly, you can do import NumPy as anything. This NP, that's just a little shorthand placeholder. You can use imported as N, whatever, makes no difference. It's just basically, if you do import as, that just allows you to rename what you're importing it to something short and more concise. And if you want to be super, super short and concise, you can just do from NumPy import star, but I would recommend not doing that because you could potentially run into issues where if NumPy has, say, if NumPy has, actually NumPy does have, so you have np.sign, okay, that's a function. But there's also math. That's also functions, okay. So if you did a from math import star and from NumPy import star, whatever was the most recent one, those are the symbols that you would end up using, and then you'd end up basically what's called collisions. And yeah, if you know what you're doing from NumPy import star, it's great. I would recommend just doing the as, okay? So make an array. We do A equals equals np dot array. And then okay, so we need to do just a little syntax here of numpy.array. That's actually a function, okay? And then we give it a list of numbers, and then it converts that Python list to an actual real array that we can do math on it. Okay, so we got the type, oops. And n-dimensional array. Okay, good. That array object has a variety of different methods and properties on it. So you can do a dot, let's do shape. Okay, so that means that it's a 3 rows. So it's a one-dimensional length 3 array. You can do a dot tab. Lots of stuff. Conjugate, copy, diagonal, dot. Dot product is probably something we'll be using quite a bit. We can change the elements in there. Okay, so now if we want to do an actual matrix, you can do m equals np dot array. Okay. And 1, 2, 3, comma. Oops. Oh, okay, that's good enough. Well, we have a typo here. What I do? Okay. My bad. My bad. Syntax error. Okay. So what did I do wrong? What was the typo I made? Any guesses? I was trying to give array a set of lists, but to make an array, you have to do it this way. You have to make a list of lists. So let me see if I can make this a bit clearer. Okay, let me reformat this a bit. Okay, so when I create a matrix in NumPy, I do NumPy array, calling it as function. Okay, so I make one square bracket to create my outer list, and then I do list as many as I want, and then close it and close it, and that gives me a matrix. Okay, so nicely formatted square matrix. So if I'm making a 1D1, it's simply just a one-dimensional list of numbers. If I'm making a matrix, I do have to do square to indicate that I'm giving it a list of lists, if that makes sense. Okay. And I can do m dot shape. Okay, that's a 3x3. And grab all those funnel elements. Okay. Now we can do lots of little matrix algebra here. So we can do m dot. Okay. Okay. We can do a matrix vector multiply. We can do a vector matrix multiply. You can do any of the fun little linear algebra operations you want, because all of the NumPy array types have dot product, cross product, and so forth. So there are a number of built-in functions in NumPy. We have np dot zeros, 6, 2. So that gives me a 6-row, 3-column matrix of zeros. We can do ones, np dot ones, 6, 3. Then get a tuple, 6, 3. You can add matrices together. You can do m e ones. You can do m plus e. That does a item by item add. So it does all those. This is going to be a little bit funny, but you can do m star e. Doesn't do much, but if you do the multiply, that does an item by item multiply. It does not do a matrix vector product. If you want to do a matrix vector product, you have to do the m dot e. Okay. And that does your standard matrix vector matrix product. Okay. So we can do np dot eye. That's the identity oops. Yeah, so if you do np.I, that's the identity matrix. So it's a matrix with a ones on the diagonal. Okay. Random matrices, real random matrices are definitely useful. You can do np.random.random and okay. So that created a 5x5 matrix of uniformly distributed random numbers. So random numbers distributed between 0 and 1. Okay. Arrays in NumPy use standard row major indexing. So if we do m, okay, there's our m. So we can do an m bracket. So we can do 0, 0. That gives us the 0th row, 0th column. M 0 row, 1 column. Okay, so it's 0 row 0, column 1. Okay. Slicing in NumPy works identical to regular slicing in lists. The only difference is now, instead of having one dimension to work on with a list, we now have 2 dimensions to work on. So that's why you use a little comma thing to separate your column indices. So we can do M, okay. And let's just say we want everything in there, comma 0. Okay. So who wants to give me a guess of what will happen here? So let's get a guess. Anybody? Okay. So we get the row, column. Okay. So I'm doing M, that's guy. Okay. So remember, in my slicing, if I do just a colon by itself, that defaults to everything in that dimension. Okay. So here I'm doing row, everything for the rows, and column 0. So let's get a guess. Who wants to guess as to what M colon comma 0 will return? Yeah, okay. So 146 exactly. So we grab all of the rows, row 0, row 1, row 2, because I used a colon there. But because I restricted that, 0. That's my 0th column. So rows, columns. If I did M colon comma colon, get the whole thing. We can do the same, all the exact same games that we can do in lists. So you can do M. So let's do colon colon -1, 0. Oh, look at that. Do the same thing. We grab the 0th column, but we grab these guys in reverse order. Okay, colon colon -1. So remember, when I'm using in -1 as my step, the defaults for start and stop are flipped. It's smart. Okay. So you can do sub-slices. Okay. So we can use slicing to get a subarray. Okay. So you can do M colon 2 comma 0. Okay. That gave me, so default to start and stop. And give me all those elements there. So that is 1. Okay. And we can set individual elements. No, you can use slicing to transpose a matrix, but the M dot transpose is better. Okay. So you have M, yeah. So you can do M transpose. Transpose leaves the matrix alone, but creates another matrix, which is the copy, which is the transpose copy. Yeah. Rows. So we have a matrix. do rows or columns. Those themselves are actually NumPy arrays also. So you can do m dot shape 3 by 3 m dot colon comma 1. Okay. Yeah. So m colon 1, that grabbed me the first column, and that's a vector. So that has a shape of 3. Okay. Yeah, it's actually really powerful indexing. Okay. Oh, we can do Boolean indexing. Boolean indexing is fun. Okay. We can do m. Okay, that's for matrix. So we can do m greater than 2. Oh, look at that. I did a comparison. Okay, I did a logic operation comparing a matrix to a number greater than. And it's smart enough to realize that, hey, I'm comparing a matrix to a number and I'm doing a Boolean operation wrong. So that gives me a matrix of bools. Now, I can use, this is actually fun, I can actually use those Boolean indexes to grab values out of that matrix. So I can do index equals m greater than 2. Now I can do m index. Huh. So what? Using a Boolean matrix, using a matrix of bools to index something grabs me all the elements in that matrix that meet those Boolean values. Okay. So you can actually make it really shorthand. You can do m greater than 1. M So when you guys start using Tellurium tomorrow, and you want to grab all of the elements in a result time series that are above or below some threshold, Boolean indexing it's a really convenient way of doing that sort of thing. Okay. So you can add, subtract, adding, subtracting. These are just item by item, or what's called scalar operations on them. And yeah, so the dot product is a standard matrix slash matrix vector product. And we can do a cross product. Okay, so we have A. So we got 2 random arrays, so we could do A Oh, we're cross product. Got the mean value out of there. Okay. Lots of built-in operations. Okay. So for plotting, Python has a package called matplotlib. That's actually one of the more popular plotting packages. It has quite a bit of quirks, but it's one of the more popular ones. And then to access the plotting one, you can do import matplotlib.py plot. Okay. Oh, typo. Okay. So we can go ahead and plot some functions here. So we can do x equals np dot a range. Okay. One little subtle difference here. So the base Python, we've used the range, the built-in range function. So that generates basically a sequence of integers, start, stop, step. Okay. The caveat with range is that it only works with integer numbers. If we want to do floats, you have to do a range. So just it's just the way it is. A range. So we can use 0, and then these are numbers 0 through 10, exclusive in steps of 0.1. Okay. And then you can do y equals np dot sign. Okay. And then the advantage of using the NumPy trig square root functions is those all work on array types. So they work, yeah, so we can do plot typo. And show. Okay, great. So we got a plot. There's a lot of stuff that we can do in plotting. Really, I would say, I mean, I'll go ahead and show you, I will go ahead and show you guys a few basic plotting things here. But if you want to get some of the more fancier stuff, I'd suggest going to matplotlib.org and then looking up the documentation there. There's about a million different objects and routines and so forth that you can use in matplotlib. So let's go ahead. We did a sign. We can add little labels to it. Yeah, so we can do YS. C equal NP cost. And then I'm gonna go ahead and plot more than one thing. Plot. Actually, let me clear it. There is a, I thought it was a clear method. I think I'll just override it. Okay. Not dot x comma ys dot c. So what I'm doing is I'm plotting more than one data series at the same time. And then I can put some labels on here. Plot dot x label. X. Dot label. And sure. Okay. So now I'm going to relatively painlessly plot more than one things on the same plot. And then if you want, you can do, I believe you can do plot.save. Yeah, you can do save fig. And then my fig.png. Okay, that saved it out to a file. Where did this save it out to? Who remembers at the beginning, how do we look at what directory we're in? Any guesses? Print working directory, right? Okay. So we're in this funny little session directory, and then list. And that's where I put myfig.png. What will happen here is if I close this screen and I open up a new session, there's a good chance that figure might be gone. So I would recommend copying that figure to your home directory. And you can just do simply copy my fig squiggle slash. Okay. And what that is this is basically standard standard Unix directory copy move things. So you can move copy, CP is short for copy, name, and then squiggle slash is shorthand for your home directory. So if I would do cd by itself, now in my home directory, and then my fig was there, and then I can do load. Don't know if this will work. No, okay. Yeah, I would need to look up the exact function to load an image and display it. I don't know exactly off the top of my head. So that's basically plotting. Let's see. So on the next time, I think we'll go ahead and leave dictionaries off We'll cover dictionaries on next Sunday because for Torium, you really won't be using dictionaries at all. And then we'll leave. So next Sunday for the CompuCell ones, EOG. Oh, okay, thanks. EOG. Oh, okay, not sure what EOG is. Okay. Yeah, there was a transfer. Okay. So on next Sunday, we'll cover some of the more some of the capabilities that you'll be using really heavily in a CompuCell program, such as dictionaries and classes. So to get you started on Tellurium, what you'll 90% of your work will be using NumPy to look at results and to perform various statistics on them. And that should get you a good basic start on Python. So I'll go ahead, I'll just leave this completely open. I'm gonna stay online probably another, I'll honestly stay online as long as anybody has any questions. I'm here to help. I'm glad to help with whatever I can. So how do you guys like the intro to Python? Ah, great, okay. So hopefully I taught you something good. Okay. Uh, Nice. Okay. So is there sure, yeah. So are there any other topics or any other little things I can try and cover right now? I mean, I'm glad to cover any material you guys feel would be helpful, or I'm glad to go over anything that was might have been confusing. Okay. So let's see. So the image that was saved. How do we see the image? Just a second. Let me Google that. See, I don't know everything. GU Twitter show. You know what? Instead of using my phone, show image. How do you display an image? Oh, it's display. Mm. I wish this was a little bit cleaner, but so you can do. So we import the image package, and then we make an image. Hmm. All right, I'm not 100% sure why that's not saving. This is honestly, this is not something I normally do. Um, okay. So when we save the fig, so when we save the figure, that saves it into your the current directory where it's configured to. So I think I should be able to do. Hmm. Okay, so this shows that my fig is a non-zero image. I'm not sure why this is not showing that. Huh. Well, this is odd because that's actually, it's opening up something. And hmm, this is interesting. Okay, I'm not really sure why Matplotlib is saving a blank image. Um, that's something I will have to look up and get back to you guys tomorrow because I'm not really used to saving figures in Matplotlib. Okay, so sorry about that. I like I said, it's something I will just have to look up for you. Yeah, it should be saving it. It should, it is saving it in its current directory. Let me see if I can download that and save it. Yeah, so it's weird. It is saving it. It is saving it. It is reading it, but Matplotlib is saving a blank image. So it's probably because I don't know how to use Matplotlib correctly. Hmm. Hmm. Oh, maybe you have to do that. Uh-huh. Um, They're both the same size. Okay. I will have to get back. Okay. Anything else we can cover today? I think we're good.